Why is it that 0 factorial equals 1? Is this a definition, or is there a proof of this? The problem is that the typical definition of n factorial is that n factorial is n times n minus 1 times n minus 2 all the way down to 1. And that definition does not cover the case of 0 factorial. It doesn't fit. So what we have to do, if we define n factorial to be this way, we have to define 0 factorial to be 1. Now, some people say, well, 0 factorial is 1 because n factorial has a combinatorial explanation, but that is an explanation of a formula. That is not how we usually define n factorial. So if you define n factorial like this, 0 factorial has to be defined to be 1. But there is a better way of defining factorials that avoids this whole issue. A solution to the conundrum of 0 factorial is to define factorial in a much broader sense. We in fact define the factorial for every real number that is bigger or equal to 0, and we define the factorial to be gamma of x plus 1, where gamma is the gamma function, which is defined by this integral, and it takes actually, z can be any complex number with the real part bigger than 0. And it is a fact that, in fact, when n is a natural number, gamma of n plus 1 is n times n minus 1 times n minus 2 times 1. You can prove that using integration by parts. And what that means is that when x is a natural number bigger than or equal to 1, we actually get the usual definition of factorial. So that's nice. But this is better because now we can evaluate it at, well, at any real number x, or we can evaluate it at 0. So now I can evaluate it at 0 factorial. By definition, that's gamma of 1. Go to the definition here, put z equals 1. So this becomes t to the 0. So I get this integral, which is this integral, an improper integral that I can compute using limits. And the limit of this, since this goes to 0 as b goes to infinity, is 1. So what I got is that gamma of 1. So 0 factorial has to be 1.